Hi everybody, as I announced earlier this week, I said I was going to be making online videos of my sessions I had this week, and they will pretty much be covering the entire homework assignment for homework number 1, chapter 6. Alright, for this one, let's start out. This is the first problem. It's part B of the first problem. It says a mole of X reacts at a constant pressure of 43.0 atm via the reaction X plus 4y equals 2z, with a delta H equals minus 75 kilojoules. Before the reaction, the volume of the gaseous mixture was 5 liters. After the reaction, the volume was 2. Calculate the value of the total energy change, delta E, kilojoules. Well, before you can even go approach this, you need to know a few things. I'm going to write them up right here. Delta E equals Q plus W. Alright, these are just letters and stuff. What's that mean? Well, Q means heat. And if you look into the problem, it's actually given right here. Delta H equals negative 75 kilojoules. So that value is just given. Why don't we just write that out here so we know? 75.0 kilojoules. Perfect. Now, what does W equal? W stands for work, so W equals work, and we're going to represent it like this. Negative pressure multiplied by delta V. What does delta V mean, if anyone has any curiosity for that? Delta V equals the volume of the final subtracted from the volume of the initial. Delta means change. So what does this look like when we put it all together? Let's see. We got delta E equals Q, which is delta H, minus P, pressure, multiplied by the change in volume. So right here is the formula we're going to go be working with. Now, there's still a few manipulations and conversions we'll have to deal with, and I'll show you how to do that coming up right now. Let's just go to the next page. I'm going to bring over some things that I had before. We had delta E equals delta H minus P delta V. So what do we know and what don't we know? We know that the Q was given, which was the heat, so we can just write that as Q equals negative 75.0 kilojoules, which equals delta H, right? Perfect. Now we have to figure out the work. Well, let's look at the formula for work. Work equals minus P multiplied by delta V. So delta P, minus P, what is that? That's already given. Up here, as you can see, it says 43.0 atm. So work equals minus 43.0 multiplied by the change in volume. Well, what's the change in volume? You just have to look over here. Change in volume is, oh, I'm sorry guys, it wasn't supposed to happen, but the change in volume is 2 liters and it turns into 5. So let's do that out. 2.0 minus 5. Well, we shorten that up a little bit. Work equals negative 43 multiplied by minus 3, right? And then when we multiply that out, we get work equals positive 129. Now, what are the units? ATM multiplied by L. Alright, so what does this mean? Can we just do 129 multiplied by 75 kilojoules? No, we can't because the units aren't the same. But you would be given on a test, or just in general, you will always be given 1 ATML is equal to 0.101 kilojoules. So that's very helpful, right? All you have to do now is get 129 atm into kilojoules, so that's simple. It's just 129 multiplied by 0.101. When I did that out, I got about 13.0 kilojoules. Alright, so now let's go back to this original formula up here. So we see that we have this one right here. Oh, sorry about that, guys. We have delta E equals delta H minus PV. And that, even more simplified, equals this. Delta E equals Q plus W. Well, look at this. We already know everything. We know Q, it was given, minus 75, and we know W because we just calculated it out. So we get delta E equals minus 75 plus 13.0. And I got roughly delta E equals negative 62.0 kilojoules. And that's what I got for my answer. If anyone has any questions, we can go over this in class more. Before we get on to this next problem, I just want to do a little review. We have system and surroundings. We talked about this in class, right? We have the system and surroundings. The system is whatever you choose it to be, and the surrounding is literally just everything else. So, what does that mean? Sometimes the system does work, sometimes the surrounding does work, and how do we know whether that work's going to be positive or negative value, or if it's gained? Well, let's put this in a table, sorry. Let's make a little table like this. And as we know from before, Q stands for heat, W stands for work. So, let's see. What happens if the system gains energy? How is that represented? Is that represented as a positive value or a negative value? Well, think about it. It's gaining, so it's getting extra. It's not having to put anything out, so it's going to be represented as positive when the system gains or absorbs. Now, what happens if the system loses energy, loses heat? It's going to be represented as a negative. So that's what happens when system loses. Now, what happens when the work is done to the system or around the system, when the work's being done by the surroundings? That's going to be a positive value when the work is done by surroundings. But what happens if the system is doing the work? That means it's negative when the work is done by the system. Now, if you're wondering to yourself, why am I going over this right now? This next problem, you're going to need to know this information. So, if you want to write this down so you can look at this on the next problems, that'd be very good idea. So let's go over and start it. Exercise 6.10 states a system absorbs 711 kilojoules of heat and the surroundings do 520 kilojoules of work. Alright, well, if we look back at that chart I made earlier, we can figure this one out easily. So first off, let's write this out. We have delta E, which is what we're solving for, equals Q plus W. Q is heat, W is work. Let's look at this. 700 kilojoules of heat is absorbed, so that's going to deal with Q, right? And then 520 kilojoules of work, that's obviously going to deal with work. So are those values going to be positive or negative? It's easy to find out. A system absorbs, right there, absorbs, means it's gaining it. So that means 711 will stay positive in this calculation. Plus the work. Now, is this work going to be positive or negative? Let's see. The surroundings do 520 kilojoules of work on the system. That means the system isn't doing the work. The surroundings are doing work to the system. So if you look at that chart, it's going to be positive as well. So let's write delta E equals. Now, this is a simple math. Delta E, so 711 plus 520 equals 120 kilojoules. That's with two significant figures. And that is a value for delta E. Now, does this make sense? Let's quickly go back. 700 kilojoules of heat was absorbed. Check. Surroundings did 520 kilojoules of work. Check. Alright, let's do the next one. Alright, exercise 6.12. The air in an inflated balloon, defined as the system, is warmed over a toaster and absorbs 120 joules of heat. As it expands, it does 7 77 kilojoules of work. The first thing I like to do with this is make sure the units are lining up. I've quickly noticed that we have kilojoules right here. Oops, sorry. Kilojoules right here. Joules right here. That's a no-no. We got to have them in the same units. And if you look, the problem wants the answer to be in kilojoules, so we might as well just convert 120 joules to 0.12 kilojoules. So let's write that right here. 12 kilojoules. Alright, so let's back to the problem. Well, we just write it out. Delta E equals Q plus W. Alright, so what is what? The inflated balloon defined as a system is warmed over a toaster and absorbs. Absorbs is your key word there, right? 120 or 0.120 kilojoules of heat. So right then and there, we know one variable of this. Delta E equals 0.120 plus. Now, what's W going to be? Let's see. As it expands, it does 77 kilojoules of work. Expanding. So it's doing work. And it even says right here it's doing of work when it's doing itself. So that means that it's going to be a negative value. So since it itself is doing the work, the system is doing the work, not the surroundings to the system. So that gets represented as minus 77 kilojoules. Now let's just calculate that out real quick. We got 0.120 multiplied by negative 77. And I got a value of delta E equals negative 76.8. How many sig figs do we have here? We have 2. So delta E equals negative 77 kilojoules. Just be careful with the units. You could have had it put 77 kilojoules into joules and convert it at the end. That part's up to you, whatever you find easiest. But you just got to make sure the answer is what you that you enter in, or is you put it the right answer, what it's asking for, and you just got to make sure the units work together. All right. Now this makes sense, right? We'll review this. We have 120 or 0.12 kilojoules of heat being absorbed, which is a positive value, right here. And we have the system as the balloon doing 77 kilojoules of work, which would be negative, which is represented right there. So check plus. Smiley face.